This is the question of 2007 October November, and this is paper 1 only. During 2007 they didn't have papers like 1 1 or 1 2. Only one paper was there in a certain time June, and the question number is 34. It shows a potentiometer which has been used to compare the EMF of two cells. So when the first cell is used, which is cell X, the balance point is 0.70 meters. The balance point will be at 0.70 meters. So let me say this point is P, this point is Q, and this point is S. So it means that I have from this statement, I have got P Q is equal to 0.70 meters. Then the balance point for cell Y is 0.90 meters, which is, so I must have this PS is equal to 0.90 meters. So with this data, I have to find and one more data we have. So if the EMF cell X is 1.1 volt, which is EX equal to 1.1 volt, so I have to find the value of EY. So let us first remember that a potentiometer like this will be in balance when we have, so if I have used only this cell X, I must have at that time EX is equal to VPQ during the condition of balance, and that's equal to I. So where I is the current flowing in the circuit here, this is I, this is I into R between P and Q. So R in the portion P and Q, and that's equal to I. So I'll change this R is equal to rho L PQ divided by A. So where rho is the resistivity of the wire being used here, length is the L is the length of this segment PQ, and A is the cross section of the wire. So I can think this thing as constant, take this thing as constant, so it must be, it is K into LPQ. So therefore I can say this EX is equal to some constant K LPQ. In a similar manner, when I connect this another cell Y, I must have EY is equal to K into L. So now the length is PS, so it is PS. So if I divide this equation by this, I must have EY by EX is equal to, I cancel K and K, so it is LPS divided LPQ, which will further give me, so EY I have to find, but EX is there, which is 1.1 equal to LPS is 0.90 and LPQ is 0.70. So this gives me EY is equal to 0.90 by 0.70 into 1.1. So since this thing is more than 1, so more than 1 into 1.1 should be more than 1.1, and the only value which is more than 1.1 here is 1.4. So the value should be nearby equal to 1.4 volt, which is choice number D. Now this question can also be done in a different way. So the way is that since I have for Y the balance length is 0.90 meter and for X it is 0.70 meters. So balance length of Y should be more than balance length of Y is more than that of X, which means its EMF should be more, and the only choice where EMF is more than 1.1 is 1.4. So this is a shortcut to try this question. So the choice is choice number D.